It was the 12th century. A farmer named Ben in England bought land from a landlord named Joe. The deal was for 40,000 square feet of land in exchange for 10 gold coins. But when Ben started his land, Joe felt that Ben's scale was larger than a foot.
This stick seems longer than 1 foot. That way, you'll take more land.
How do you know that this stick is not 1 foot long?
We measure it with our 1 foot stick. Everything will be clear and sorted.
But how can I believe that your stick is exactly 1 foot?
Said that we measured it just yesterday with Johnny Carpenter's scale.
Johnny's scale came from the sky. That could also be wrong.
After hours of debate, both Sahar staff both went to the royal court with their problem and told the whole story to the king.
That's all there is to it. Such disputes have happened before. That's why my great-grandfather, King Henry, had a 1 foot rod placed in their basement, which, after measuring, would confirm whose rod is correct.
After hearing the king's words, a question arose in Ben's mind.
But, Your Majesty, how were those rods measured? The scale used to measure them could also be incorrect.
Such insolence, fool. It was not measured by anyone. 1 foot was the length of 1 step of our great-grandfather. He is the originator of this unit. Bring the real scale from the basement. But when they went to the basement, they found that there was no stick there.
There has been a theft in the basement. So how will our problem be solved now?
To prevent such problems in the future, scientists devised a smart way to measure units. Using natural constants, there are 7 fundamental physical quantities in physics, using which we derive the rest of the quantities. Natural constants are used to define these fundamental quantities because unlike a physical object, they cannot be stolen and their value, they do not change with time. Measure them anywhere in the universe and you get a fixed number every time. For example, to define the unit of time, the frequency of microwaves that take a cesium atom from a lower to a higher energy state is used. Count the oscillations of this microwave, sequence at semi-density, then it will be 1 second. For the energy states of the cesium atom, this microwave never changes. Similarly, the speed of light is also constant and 1 meter is equal to the distance that light travels in a vacuum in 1,299,792,458 parts of a second. Measure this length anytime, it will not change. Similarly, other units are also derived from some natural constant.
Now how do we measure the speed of light? What about our problem?
The answer can only be found in the comments.